Hello and welcome to topic number 7 of the OCR GCSE computing course. We're looking at software today. The last 5 or 6 videos have all been about hardware, and today we're cramming everything into one video about software because if you've noticed, I'm following the specification as it lists it and lists all of this stuff in the same chapter, the same topic, so I'll be following it like that. So a lot to cover in today's video. Let's start with recapping what hardware is. So hardware is the physical parts that make up a computer system. Software are the programs used to control a computer system. Pretty standard, just want to make sure it's nice and clear before we begin. So first of all, we've got to look at what is known as an operating system. Hopefully you would have heard of what this is, but essentially it's the essential software. Your computer needs an operating system for human interaction to take place. As you'll see, but basically what it does, it links the hardware and other software, so other applications, other programs together. And if you can look at a diagram here, so you can see we've got the user who interacts with the applications, the other programs on your computer, and those applications interact with the operating system, and they allow through the operating system they allow access to the hardware. So it sort of bridges the gap between the applications and the hardware. You can think of it like that. So it's essential software that links it together with other software, which is slightly hard to understand, but if we look at some functions in the next slide, hopefully that will clear it up. So let's just have a look at 3 examples. So Android, Linux and Windows are 3 examples, and iOS on your Apple devices, etc. Lots of operating systems that are used by lots of people because it's essential, obviously. So if we look at some functions of an operating system, the functions are the same for every operating system. It's not brand or company specific. So in a operating system, you have what is known as the kernel element. Kernel, I find it absolutely bizarre that the word is kernel, because I just think of popcorn kernel. But I guess it's this little nugget, I don't really want to say that, but nugget of code in the operating system code that manages the tasks of the computer and the hardware. So the way I like to think of it is sort of a king program as it rules over all the others. By the way, the specification does not list you need to know about kernel, but if I show you in a minute, it'll make clear why I'm talking about it. So you can see there's a little bit of a kernel. It interacts with the applications, and through that the hardware can be accessed. So an important function of the operating system, and specifically the kernel, through the kernel it works, is memory management. So the kernel has complete access to the memory of the computer, and its role is to safely allow access to the memory that the programs require. So essentially the kernel's job is to manage memory access. It makes sure that multiple programs, if you're running multiple programs at any given time, it makes sure that they don't all interfere with the same memory. For example, if you are trying to change a file name, you can't change a file name or edit anything to do with the file while it's already open. So say if you have a Word document already open, you can't then change the file in Microsoft Explorer, for example. So that's the function of memory management. Also, it plays an important role in multitasking on the computer. So instead of processes happening sequentially, which just simply means one after the other, so instead of the processor simply sort of ticking off the list of processes and doing them all after each other, so in a nice list, the kernel does allow programs to work concurrently, and concurrently means it can overlap. So they're not running parallel, so they're not running each at the same time, but they are overlapping slightly. So they're using one function of the CPU at one time, and then another program is using another section of the CPU to do something, and the kernel allows this to happen. And this gives the user the impression, and does allow you to multitask on your computer. You can have lots of programs open, and processes can happen concurrently, so almost at the same time, and this is a function that your operating system does. So if you look at some non-kernel relating things, like I say, you don't specifically need to talk about a kernel if you had an exam question, but if you want to impress the examiner, then you can talk about the kernel. So other functions that don't really involve it are to do with the user interface. So the user interface is sometimes referred to as the shell. So in Python, if you code with Python, you call it the Python shell because your interface to code in Python is the program that you use, and the user interface is essential for human interaction. If there wasn't anything there, clearly you can't do anything with it. And a user interface can be as simple as a command line, which was used in the past. So this is a picture of a command line. Often when you start your computer off, you'll get some command line prompts. There's also, you can use your CMD, which is a command line something, just to do certain instructions to your computer. It was used in, like here, 1980s onwards. MS DOS, disk operating system, I think is what it stands for, was used, and it was purely command prompt. But nowadays we have what is called graphical user interfaces. Lots of people like to call them GUI. That's the acronym, but lots of people like to pronounce it GUI instead of GUI, but it doesn't really matter. Unfortunately, these are far more easy to use because you have pictures, you have icons, you have yeah, it's just generally easier to use. It's obviously far easier to use than command prompt. So another function of an operating system is to provide security. So it will do this to a certain extent. Often you'll like to buy or download other programs that help with security, but what it does, it must be able to distinguish between legitimate program requests and illegitimate ones. So on your computer, say if you had a virus or a program that's not designed to be there, it's got on your computer, maybe accidentally you downloaded it or someone has deliberately put it on your computer, it needs to realize which requests from programs are real and which ones aren't. So a request from Microsoft Word will be legitimate, one from a virus will be illegitimate, and it does this by basically authenticating each request. You don't really need to know too much how it does this. I don't really know how it does this. I guess it's unique to each operating system, but it just basically checks it and checks each request to make sure they're legitimate. Clearly, these programs, the illegitimate programs, are designed so that they can trick the operating system, and that's when you'd perhaps want to use a third-party program which is maybe better designed and up to date as well. So finally, the last function that you need to know about of the operating system, these are definitely not a complete list. These are probably the most basic functions that are useful to know about. So peripheral management. A peripheral device is a piece of hardware that interacts with the computer. So an example of a peripheral device is a keyboard, a graphics card, and monitor. And the operating system's job is to make sure they work. It manages all these peripheral devices, and they use what are known as drivers. So often if you install maybe a mouse, automatically you'll get a little balloon popping up saying that you're installing the drivers, and it does it for you. It ensures they're up to date, ensures that everything's working together by using drivers and using other software that are designed to work with each one. So that's the final function. You probably need to briefly mention each of these if there was an answer, or you might get given an example to talk about security or talk about the user interface, and you might it might be a 2-mark answer, 3-mark answer. Just briefly explain what it's about and explain why it's needed. So this slide, I better get some water. This slide is all about utility programs. So this slide took me ages to do because my brilliant idea was to try and fit it on one slide, which is quite difficult. So we've got to look at 3 types of utility programs: security, disk organization, and system maintenance. And these are 3 sort of genres of utility programs. And these are programs that are used to, how can I define utility? Used to help you in some way. So let's first look at security. So on your computer, you may pre-installed to have some antivirus software. And antivirus software are programs that detect and eliminate malicious software. So software intent on damaging your computer or deleting stuff. It's quite a general term, virus. It can just basically you don't want it to be there. And on your computer you'll have some kind of antivirus installed usually, but people like to download their own ones because, like I mentioned before, they're often not up to date, because hackers are designing new viruses daily and they'll use the latest techniques, and the latest antivirus should in theory sort of catch up with them. So you want to make sure your antivirus is up to date so you can download that from a third party company. Also, you'll have firewalls installed on your network, and these are a network system that control and filter incoming and outgoing traffic. So you can think of it like a wall that filters through incoming and outgoing traffic, making sure that you're not connecting to websites that are dodgy, websites that are going to install spyware. Links on to my next point quite nicely. So yeah, that's what a firewall does. It filters everything on your network. So spyware protection. Spyware is a type of software that gathers and sends information about you. So if you have spyware on your computer, it will gather information about you, maybe your passwords, your you might have a keylogger, so it records whatever you type, and if it sends this to a hacker, they can gather all this information about you and use it against you. So an example of this is a Trojan. You don't need to know what a Trojan is, but it's just an example of software that's spyware. And most spyware protection programs simply block the threat. So it's difficult to eliminate them, but some try to eliminate them. I'm not sure how they do, but it's easy to simply block them by making sure they're not downloaded or making sure they can't do anything too dangerous. So if you look at programs to do with disk organization, there's one you built into Microsoft Windows, at least, and I'm sure almost every operating system, there's a program to do formatting, and this is the process. This allows you to partition sections of your hard drive before files are stored. So this is sort of an automatic process that simply prepares your hard drive, your secondary storage, to have files stored in it. So often some people like to do this themselves. So some people like to have an SSD and a hard drive working together, and on the SSD they might have the operating system stored on, because that loads it up really quickly because it's got a fast read-write time, as we looked at in a previous video. And this is a form of partitioning, and you would use a formatting program to do this, and they're usually pre-installed, but I'm sure you can download third-party ones that may be best designed. Another disk organization tool, another program, is a defragmentation program, and essentially when you have lots of data or stored in your hard drives, they can get scattered about. Data can be stored on each end of a platter on a hard disk. So on the disk, the data for one program maybe is sort of scattered about, and naturally, especially with hard drives where it spins, it has to retrieve all these little bits, and it has to access them either side of a disk. It has to travel a long distance, which slows it down. So defragging a disk essentially reorganizes related data, and when it organizes the data, they're stored together on the hard drive as opposed to apart, meaning that they're accessed quicker. Don't need to know this in too much detail, but I would just, if you got asked about it, just write what I've written there. There are also file transfer programs. So these programs allow files to be moved around, copied and deleted by the user nice and easily. An example of this is so Windows Explorer, which is actually a program. You go into My Computer, you go into My Documents, that's actually a program that allows you to do that, and it allows you to copy, delete, move around data, and files I should say, and that's a program that allows you to do it. You might not recognise it as a program, but it definitely is. So if you look at system maintenance now, there are system cleanup tools, so system cleanup programs, and these speed the performance of a computer up by deleting files that aren't used, files that maybe are from programs that have been deleted, that weren't removed properly. It basically cleans your computer up, which in turn improves your performance. Also, you have automatic update programs, so these you have them automatically installed on your computer. Like you have a Windows automatic update program, but for example, iTunes, I find it really annoying whenever I go on iTunes. Apple always gets me to try and automatically update them. I always click no. But these are programs that search online, find and download software that have a new update. So if a developer releases a new update for some software, these programs will automatically find it, download it, and maybe even install it for you, which is meant to be easy for you, save you time, but quite often it's a bit annoying. But still, that's quite a useful program in some contexts. Finally, on this slide, we've got to look at system information and diagnostics. So these programs, basically, the system information part, they keep the specifications of your hardware. So if you go to My Computer and Properties, it shows you all the, for example, your clock speed, how much RAM you've got, your hard drive capacity, and those specifications are just stored in that simple program. And through diagnostics tools, if a doctor diagnoses you with something, it means they are working out what's wrong with you. So if they diagnose you with a cold, it means you have a cold. And a diagnostic program will check if whatever you're looking at is functioning right, and if it isn't, it might even suggest how you can fix it, which is very useful. Okay, a lot of information there. Maybe go back and pause if you're struggling to take it in. It's hard for me to speak, let alone read and understand, so I do apologise for that, but I was trying to be as organised as possible. So finally, we've got to look at 4 types of software. So first of all, we're going to look at what custom written software is. So custom written software, as the name implies, is software that's currently available to buy or download for free. Oh no, sorry, not download for free. basically, custom written software is software that is being designed specifically for you, because there's software out there that doesn't meet your needs. So if you want software to do a specific purpose, for example, I don't know, opening a door for you, opening your garage door, and software isn't currently out there to do it, you may either code it yourself or employ someone to code it for you. So naturally, custom written software does exactly what you want it to, but especially so it takes a long time if you're writing it yourself, or even if someone else is writing it for you, and it can be very expensive to have someone code it specifically for you. And if something goes wrong, there's no real help available. For example, if you are coding a simple program, you can often Google it, and a forum will have some information on it for you, might help out. But if it's your own specific use, there probably won't be much available to help. Another type of software is off-the-shelf software, and these are programs that you can buy that are aimed at meeting lots of needs of users. So basically, off-the-shelf software, they try and please everyone. For example, Microsoft Word has lots of features. It's probably got hundreds of features, but how many would you actually really use? Maybe 10, 15. So you have features that you'll never use, but maybe someone out there will use them, and they're designed to sort of please everyone. The generic software such as Microsoft Word, PowerPoint, Photoshop, maybe these types of software. So they're not custom written, that's the point, and they're relatively cheap because lots of people buy them. There's a huge demand for these off-the-shelf softwares because they meet so many needs of users. A bit of economics for you, and they're thoroughly tested, so usually bug-free, because they're usually by lots of big companies like Microsoft, and there's lots of help available. So if something goes wrong, often they'll have a website that has an FAQ, some help section. You may even be able to call them up and ask them about it. So there's lots of help available, which is obviously a positive. Penultimately, open source software, and this is a type of software with the source code, so the code that's been written to program the program. I don't really like that, but yeah, what have I written here? So it's code that's freely available, so you can download it for free usually, and it's because they provide the source code, anyone can use it and modify it. So you can even adapt it to your own needs if you really want to, and it's usually free. I don't know in many cases when it's not free, but I read some of it's usually free. But you could probably get away with saying it's free. And finally, proprietary software is software that's commercially available but with licenses. So unlike open source software, in fact they often call it closed source, but I'd write proprietary. I can't even say it now. So you usually have to pay for it, and the source code isn't available. It's often copyrighted, maybe even patented, depending on the circumstances, meaning that you can't modify it or reverse engineer it. Reverse engineering is when you get your final product and work backwards. That's how the NSA listen in on people's conversations and things. So yeah, you can't edit it. The source code isn't made public, but so a downside is that it does cost money usually, but updates are usually free, meaning that if you buy software, they'll often update it for you automatically, and you don't have to pay for it anymore. It's also very well tested. There won't be many bugs, and it also, another downside is that it may not be specific to your needs, because it's commercially available. It's not designed for you per se. But that's it. This has been I think the longest video I've ever made. My voice is nearly lost, so rewatch it if you've got time. Hopefully it made some sense. It's not actually the hardest topic once you understand it, but it is a bit daunting. So thanks a lot for watching. Well done if you've got this far, and yeah, I'll see you in the next video.